Hello students, today we are going to read the subject control system and component. This subject, it is the first class of the control system and component. In the first class we were going to discuss about what is the control system, types of control system, what is open loop and closed loop control system, differentiation between them, and lastly the advantages and disadvantages of a control system. First we have to discuss what is the definition of a control system. A system is a combination of number, equipment or components connected in a sequence to perform a specific function is known as control system. In a system, when the input quantity is controlled by varying the input quantity, then the system is called as a control system. A control system which provides the desired response by controlling the output. In the this figure represents the following figure, shows the simple block diagram of a control system. The control system here, the control system is represented by a single block diagram. Since the output is controlled by varying the input, that's why we called it as a controlled system. When we will vary the input with some mechanism, the output is controlled. That's why we called it a control system. In a control system, the variations in the output quantity are continuously through the feedback and compared with the input quantity. Next, these figures represent a figure of a controlled system. About the next, we will learn what are the basic components of a control system. First component is plant, the second component is feedback, the third component is controller, then the component is error detector. Error detector. The first component is plant. Plant is the portion of a system which is to be controlled or regulated is called as a plant or processor. The unit which is to be controlled or which is to be regulated is known as a plant or process. It is a unit where actual processing is performed, and if we observe in the above figure, the input of the plant is control signal generated by a controller. Going to the previous figure. In this figure, the input of a plant is controlled by a controller to obtain the desired output. Then comes to the error detector. The function of the error detector is to compare the reference input with the feedback signal. When error detector is present in a circuit or in a system, its function is to detect the comparison between the with the help of the feedback signal. It compares the error, the actual value, and the difference between the measured value and the desired value, actual value, true value. It produces an error signal which is a difference of two inputs, which are reference signal and a feedback signal. The error signal is fed to the controller for necessary controlled action. This error signal is used to correct the output if there is a deviation from the desired value for obtaining the desired value. Then comes the term controller. The element of a system within itself or external to the system which control the plant is called as a controller. The instrument or the element of a system which controls the function of a plant is called as a controller. Next, we are going to discuss about what are the classification of control system. Based on some parameters, we can classify the control systems into the following ways. Control systems are classified in various manner, but here we are considering continuous time and discrete time control system, SISO and MIMO control system. Full form of SISO is single output, single input and single output. MIMO full form is multiple input and multiple output control system. Then the third one is open loop control system and closed loop control system. Going to the first type, that is continuous time and discrete time control system. The control system can be classified as continuous time control system and discrete time control system based on the type of the signal used. In continuous time control system, all the signals are continuous in time, but in discrete time control system, there are one or more discrete time signals which will be discrete with respect to the time. That's why it is called discrete time control system. Next, going to the single output, single input and single output control systems. Control system can be classified as single input and single output control system and multiple input and multiple output control system based on the number of inputs and outputs present. Number of how many if a single input and single output is given, then we call this single output and single input control system. If the number of input and output is more than one, then we will call it multiple input and multiple output control system. Then going to the next, open loop and closed loop control system. Control system can be classified as open loop control system and closed loop control system based on the feedback path. The naming of the open loop and closed loop control system is depends on feedback path. Feedback means the output of the system is further connected to the input of the system. That is feedback. In open loop control systems, output is not feedback to the input. Here the figure, this figure is represents the open loop control system. In open loop control system, output is not feedback to the input, so it is called open loop control system. The control action in this type of system is independent of the desired output. The following figures, this figure shows the open loop control system. Here an input is applied to the controller and it produces an actuating signal or controlling signal. This signal is given as an input to a plant or process which is to be controlled. So the plant produces an output which is controlled. The traffic light control system which we discussed is a best example of open loop control system. Next, going to the closed loop control system. In closed loop control system, the output is feedback to the input, so the control action is dependent on the desired output. The output is in closed loop control system always depend on the feedback. The following figure, this figure shows the diagram of a closed loop control system. Closed loop control system. Next, going to the part of this presentation, the closed loop control system have information about the change in process with respect to change in input. In this combination, in closed loop control system, the output of the control system is adjusted automatically till we get the desired responses. Hence, the closed loop control system are also called the automatic control system. Traffic light control system having sensors at the input is the example of closed loop control system. Here, the traffic light control system is the example of open loop control system, but in the closed loop control system, the traffic light system having sensors at the input is the example of closed loop control system. In the next session, we will discuss the difference between the open loop and the closed loop control system. Here I will give you in a tabular format what is the difference between open loop system and closed loop system. In open loop control system, the control action is depend of the desired output. But in case of closed loop control system, the control action is independent of the desired output. Then the second point gives feedback path is not present in an open loop control system, but a feedback path is present in case of a closed loop control system. Then open loop control system is also called as non-feedback control system, and the closed loop control system also called as feedback control system. Then in open loop control systems is simple to construct and these are very cheap, but closed loop control systems are very difficult to construct or design, and these are very costly, and the accuracy rate in open loop control system is very less, but in case of closed loop control system, the accuracy is very higher. Accuracy is present in closed loop control system. Open loop control systems are generally stable, but in case of closed loop control systems, sometimes it becomes unstable under certain conditions. The operation of an open loop system is affected due to presence of non-linearities in the elements. In the terms of performance of closed loop systems, It is adjustable to effect of non-linearities present in its element. Then we are going to discuss about the advantages of an open loop and disadvantages of both open loop and closed loop control system. The open loop systems are simple and economical. They are easier to construct, and it is very convenient, and it is very economical, cheap. These are the advantages of an open loop system. Disadvantages: the open loop systems are inaccurate and unreliable. The changes in the output due to the external disturbances are not corrected automatically. The loop systems are stable. These are the advantages and disadvantages of open loop control system. And what are the advantages of closed loop control system? The closed loop control systems are accurate. They are accurate even in the presence of nonlinearity. They are more stable. They are less affected by noise. Disadvantages of closed loop systems: they are complex and expensive. The feedback in closed loop system may lead to the oscillatory responses. More care is needed to design a closed loop system. The overall gain of the system is reduced due to the presence of the feedback. These are the advantages and disadvantages of the closed loop control system and open loop control system. These are all about what is control system and types of control system. With this, we will conclude this class. In next class, we will further discuss about classification of control systems or other aspects of control systems. Thank you, students.